So this is the Unit 1 study guide video. So I'm going to show you how to do all these problems, and hopefully it will help you get ready for the test on Friday. So for question number 1, we're going to find the 6 trig ratios for the angle. Okay, so when it asks you to find this, it's not asking to find what angle Q is, it wants to find the 6 trig ratios. So that's a very important piece. A lot of students will try to find Q, but it didn't ask you to find Q, we want the ratios. So for sine, we have opposite over hypotenuse, so 5 over 13. For cosine, adjacent over hypotenuse is 12 over 13. Tangent is opposite over adjacent, which is 5 over 12. For cosecant, secant, and cotangent, you're just the reciprocals of the corresponding trig functions. So cosecant is reciprocal of sine, so it's going to be 13 over 5. Secant is reciprocal of cosine, so it's 13 over 12. And cotangent is reciprocal of tangent, so it's 12 over 5. One thing to note, if you can reduce those values, those ratios, you have to, okay? Same thing for number 2, we want to find the 6 trig ratios, right? But in order to do that, we need to find the hypotenuse. So we're going to use the Pythagorean theorem to find that. So we have 8 squared plus 5 squared equals 89. And then the C value will be the square root of 89 because 89 is C squared. Okay, so I'm going to put that here just to help me visualize it. So sine of theta is going to be opposite over hypotenuse, so it's 5 over root 89. Now, as we mentioned when we started these problems at the very beginning of this unit, you have to rationalize that denominator. So you multiply by the square root of 89 to the top. You will get 5 root 89 over 89. That is a 9. Make it prettier. Okay. All right, for cosine, you have adjacent, so you have 8 over root 89, which gives you 8 root 89 over 89. And finally, tangent is opposite over adjacent, which is going to be 5 over 8. Cosecant will give you the square root of 89 over 5. Secant will give you the square root of 89 over 8. And cotangent will give you 8 over 5. Again, if you could reduce those fractions, you should. In these cases, you can't, so you don't have to. Okay? And again, it does not ask you to find what theta is. It asks you for the ratios. Okay, next, that B should be on the other side, but that's fine. All right, we want to find the measure of angle theta for each triangle. So for this one, we're given 3 sides, but so that means you can use any trig function you want. In this case, we are trying to find what theta is. So we're going to have, I'm going to use sine because why not? We have 7 over 25. Oh, let's back up a second, just so I have this right. Sine of theta equals 7 over 25. Okay, that's the setup. So this is, again, power standard 3.2. And then the answer, you're just going to do the inverse sine of 7 divided by 25. And give you theta is equal to 16.26. And that answer is going to be from power standard 5.3. So that's 2 pieces to this question. Okay. The next one, you're only given 2 sides, which means you're restricted on which trig function you can use. We're given the opposite side and the hypotenuse, which means we're going to again use sine of theta is equal to 11 over 20. Inverse sine of 11 divided by 20 will give you theta is 33.37. Moving on. Find the side length, the length of side C. So we're given the opposite and the adjacent, or sorry, the hypotenuse. So we're going to use the sine of 33 equals the opposite over the hypotenuse. Okay, with this being our problem, that's the setup. We just have to solve this. So we have 5 divided by the sine of 33 gives us C is equal to 9.18. of to find A, since we're given the opposite and the adjacent, we're going to use tangent. So the tangent of 25 is equal to the opposite of A over 19. So 19 times the tangent of 25, A is going to equal 8.86. Okay, now the things I'm showing you here are all the things I expect to see on your test. I don't need to see all the work. I need to see the setup, and I need to see the answer. All right, for 6A and B, these are the exact ones. These are the specialty triangles, the 45, 45, 90, the 30, 60, 90. So we're looking to find out, using the sides that you're given, to find the exact answers, okay? So in a 45, 45, 90, this is the x side. This is also x, which means this is x root 2. If x is 14, then y is 14 root 2. For 6b, across from the 30 is x, across from the 60 is x root 3, and across from the 90 is 2x. Those are relationships between the sides. So if the x root 3 side is 6 root 3, that means x is only 6. So y is going to be 2 times 6 is 12. Okay, if you solve that using right triangle trig, I'm not going to give you full credit. Okay. Number 7, find the areas of the following triangles. Now the first one has a side angle side, which means it's going to use a specific formula for this. I'm going to scroll back to the top to show you. These are the two formulas for the area of a triangle. The first one's going to use this one. The second one's going to use this one. The reason is because in the first one we have an angle, in the second one we don't. So here's our first one. So it's going to be 1/2 times 5 times 8 times the sine of 44. So you just plug that into your calculator. 1/2 times 5 times 8 times the sine of 44 gives you 13.89. Okay, the next one, before we can put that into the formula for the area, we have to find the S value. To do that, we're going to take all our terms, 7 plus 10 plus 15, and divide it by 2. Make sure I did that right. Yes, I did. Okay. All right, so that's to find the S value. So I'm going to put S right there. So we have 7 plus 10 plus 15. Divide that by 2, we're going to get 16. All right, now we can put that into the formula for the area. So we're going to have 16. I'm going to put in parentheses the S minus all the sides. So 16 minus 7 is going to be 9. 16 minus 10 is going to be 6. 16 minus 15 is going to be 1. I have to multiply those together and then square root it. So we have 16 times 9 times 10 times 6, sorry. And then the square root of that answer gives me an area of 29.39. Okay. All right, for 8 and 9, these are right triangle trig problems that you have to draw the picture for. If there's no picture, then you lose the points for Power Standard 1.1. So here's a slide. Okay. There's the little steps for the slide. It's beautiful. Okay, so the slide is 3.9 meters long and makes an angle with the ground while the ground is in the bottom. So this is where it makes an angle of 35 degrees. All right, how many meters to the top of the slide above the ground? So we want to know what this x is. Okay, so that drawing itself gives you 1.1. Now you have to translate that into an equation. So we're given the opposite and hypotenuse. So it's going to be the sine of 35 is equal to x over 3.9. All right, that's 3.2 as a power standard. So we have 3.9 times the sine of 35 to find our answer. X will be 2.24 if we round up. There you go. Number 9, the angle of elevation from a point on the street to the top of a lamppost. So we're going to have a lamppost. We're going to have a little lamppost. It's a beautiful drawing of a lamppost. All right. So the angle of elevation from the point on the street to the top of a lamppost is 22 degrees. The lamppost is 8 feet tall, so that's 8 feet tall. How far is the point on the street to the base of the lamppost? We want to find x. Okay. So this is going to be a tangent problem because we're given the opposite and the adjacent. So the tangent of 22 is equal to the opposite, 8 over x. All right. Again, picture is worth points, the equation setup is worth points, and now the answer. So 8 divided by the tangent of 22 gives you x will equal 19.8. All right. Moving on. Now we get into the laws of sines and cosines. Again, for each of these problems, you're looking for a pairing, an angle with its corresponding side. Okay. And number 10, we have angle C, side A, and side B. There is no corresponding side and angle, thus it must be the law of cosines. So here we go. We're going to go C squared is equal to 6.5 squared plus 9 squared minus 2 times 6.5 times 9 times the cosine of 52.5. All right, so we're going to plug that all in our calculator all at once. So I have 6.5 squared plus 9 squared minus 2 times 6.5 times 9 times the cosine of 52.5. I'm going to take that answer and then square root it, and I will get C is equal to 7.21. Number 11. I have an angle. I have an angle A, an angle B, and a side B. Well, because these are the corresponding pairs, I know this is going to be a law of sines problem. So I have the sine of 27 over 10. I have the sine of 105 over A. Okay, so I'm solving for this. So I have 10 times the sine of 105. I'm going to divide that by the sine of 27. And I will get the side of A is equal to 21.28. Number 12. Again, I have a pair. I have side A, side B, and angle A. Because these two are corresponding sides and angles, I know I'm going to again use the law of sines. So I have the sine of 50.7 over 10.1. And I have the sine of B over 18.2. Okay, so I have 18.2 times the sine of 50.7. That's the cosine. Sine of 50.7. I'm going to divide that by 10.1. Now the inverse sine of that answer, which gives me an error message. So that means this is a no triangle. Okay, a triangle cannot exist with those side lengths and that particular angle, because that one leg of the triangle won't touch the base of your triangle. It will just kind of hang in the air. Number 13. Again, we have a corresponding side and angle, so we again know we're going to use the law of sines. So we have a sine of 35 over 7.5, sine of B over 12. Okay, so we're going to multiply it out. 12 times the sine of 35 divided by 7.5. Inverse sine of that answer gives me 8.8. Oh, sorry, I made a mistake when I was doing something. I forgot the 1 for the 12. So it should be 12 times the sine of 35 divided by 7.5. Inverse sine of that answer. There we go. That makes more sense. Okay. So quick thing. That didn't really make a lot of sense for that angle that I calculated because I missed the 1 when I was typing in 12 for my problem on my calculator. All right, so that was a clue that I did something wrong. So you can always go back and check your work. So actually, B is supposed to be 66.6. All right, now because we solve for an angle, it is very important we check to see if that another angle exists for this problem. So I'm going to take 180 minus 66.6, and I'm going to get 113. Now I have to check to see if that works by adding that with the angle that we were given in the problem, the 35, to see if that is less than 180. And it is, so that means both of them work. Now if the angle we had originally, the 35, was something that when it added together with the 113 was larger than 180, then that angle wouldn't exist. Okay. In this case, since it's less than 180, it does exist. So we are good for 2 answers for that particular problem. Anytime you're solving for an angle in law of sines, you have to check for both answers. All right, on to the word problems. To approximate the length of a lake, a surveyor starts at one end of the lake and walks 245 yards. He then turns 110 degrees and walks 270 yards until he arrives at the other end of the lake. How long is the lake? Okay, well, with the picture we have set up, we have to subtract 180 from 110 to get 70 degrees for the inside of our triangle. Okay, it's a supplementary angle, 2 angles that make up 180. All right, now, if we're looking at our picture, we don't have a corresponding angle and side pairing, so it's not going to be a law of sines, it must be a law of cosines. So I'm going to write it out. So x squared is equal to 270 squared plus 245 squared minus 2 times 270 times 245 times the cosine of 70 angle. Okay, so we can put that all in the calculator at once. We have 270 squared plus 245 squared minus 2 times 270 times 245 times the cosine of 70. That equals, I'm going to take the square root of that answer, and x is going to equal 296.1. Got 2 more questions. I think just 2 more. All right. So after the tornado, the small tree in my neighbor's yard was leaning. To keep it from falling, we nailed a 5-foot strap into the ground X feet from the base of the tree. There's a 25-degree angle between the tree and the strap. So between the tree and the strap is 25 degrees. So let's put that in here. Okay. How there is a 108-degree angle between the ground and the tree. We got that one already. How far is the strap from the base of the tree along the ground? Okay, so we want to know what x is. All right, so that 25 is important because now we can have a law of sines problem. We have a corresponding angle inside. So we have the sine of 108 over 5 is equal to the sine of 25 over x. Okay, so I'm going to solve for x. We have 5 times the sine of 25 divided by the sine of 108. So the distance is 2.22. All right, lastly, there's going to be 2 questions for this. You observe 2 hot air balloons at equal altitudes. The first balloon is 12 miles from the airport, and the second balloon is 17 miles from the airport. The observed angle between them is 70 degrees. So that's what we have. How far apart are the balloons? So we want to know this distance. That's the first one. Well, we don't have a corresponding pair of sides and angles. All right, and we have a side angle side triangle, so that means we're going to use the law of cosines. So for A, this is what we're going to do. X squared is equal to 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 70. So there's the setup for the distance. So we put that in our calculator, 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 70. You take that answer and square root it, and x will equal 17.13. Okay, next, part B. All right, what angle will the first balloon make with a straight line to the airport and the straight line to the second balloon? So we want to know, what is the angle here? Okay. Well, now that we know what x is, which is this number that we just found, we can use the law of cosines to find this. Okay. We're going to have the sine of 70 over the brand new number we just found, 17.13. It's going to equal the sine of x, because we don't know that. We're going to label, actually, no, let's do this. Let's label that, I'll label that A. Sine of A over 17. So we're going to have 17 times the sine of 70 and divide that by 17.13. The inverse sine of that angle, or that answer rather, and you're going to get A is equal to 68.84. There we go. All right, and that is it. That is the review sheet. If you have questions, please make sure you get them asked and answered before you take the test. Again, it's very important you make sure your calculator's in degrees mode and not radians. And good luck.